Hello everyone. So today in this lecture we'll be discussing about a problem from Pathfinder from the chapter Method of Impulse and Momentum and System of Particles from the section of MCQ question number 23 and 24. So this is a comprehension based question and you have to find the answer of each of the questions. Let's get started. So let's read the question at first. Ends of three identical rods of length L are connected to a pivot that enables them to rotate at any direction. So this is a very light pivot and this allows the rotation of the rods about it. Now at the other ends of the rods, three particles A, B and C of mass m, 2m and 3m. Let me mark them. So this is m, this is 2m and this is 3m as shown are affixed. Initially the rods are coplanar and the angle between any two adjacent rods are 120 degrees. The particles are at rest. Now particle C is given a velocity u perpendicular to the rod connected to it and the planes of the rods as shown. In the plane of the rod, well, C is given a velocity u in the plane of the rods, means in the plane of the paper. Okay, denoting the acceleration of the particles ABC as A vector, AB vector, AC vector. What conclusion can we make? Now first question is an easy one. So considering this as the system, the net external force Fx is equals to 0. So 3m AC vector plus 2m AB vector plus m AA vector is equals to 0. From here, cancelling m, you will get option C as the correct answer. Now the question number 24 is a tricky one. It is conceptual. Now consider this to be your pivot. And here's rod, three rods are affixed to it, and this is particle A, B and C respectively. Question number 24 says that the moduli of acceleration of A, B and C immediately after particle C is given a velocity u. So particle C is given a velocity u. Since the pivot is very light, we can assume it to be massless. I am assuming the pivot to be massless. So suppose the tension in rod, suppose this is P, the tension in rod PB be T2 and PA be T1 and PC be T3. One must clarify and conclude that T1 is equals to T2 is equals to T3. Why? Since the net force on P is equal to 0 because it's massless. So T1, T2, T3 will respectively make vectors like this. This is T2 vector, this is T1 vector and this is T3 vector, and this is 0 if T1 is equals to T2 is equals to T3, that is it makes a equilateral triangle. So I can let T1 is equals to T2 is equals to T3 to be T, capital T. Hence, just keeping each of them as simply T. Now, F is equals to ma is the second law of motion. So, if F tends 0 and m tends 0, does it mean that A tends 0? Of course not. There may be finite acceleration of point P, meanwhile mass and force on point P to be 0. This is an important conclusion we have to draw to solve this problem. So let us assume point P to have accelerations ax and ay. Now assuming point P to be the frame of reference, so we have to take pseudo forces. Pseudo forces will be opposite to the direction of acceleration vector, and this is our point P, this is point B. So the force on it will be 2 max vector in the negative x direction and 2 may in the positive y direction. Similarly, another force tension is acting on B. Since B has no acceleration with respect to P initially because it does not have any radial velocity, we know that radial acceleration is given as r double dot minus r theta dot square, and also omega with respect to P for B is 0. That is why T is equals to m2 may. Equation 1. Similarly, for point A, which has mass m, this will have pseudo force equal to minus 2 max, that is in the negative x direction, and sorry, it will be only max, and may in the positive y direction. We know this is 60 degrees. So T plus may by 2 is equal to max root 3 by 2. Similarly, there is another point C, and here's are the forces: 2 max, 3 max, and 3 may. Now there is a catch in point C. Point C has some velocity with respect to P initially. So acceleration of point C along the rod will be 3mu square by L, which will be equal to T plus 3ma x into root 3 by 2 plus 3m ay by 2. Hence we gather three equations, and solving for each, you will get first thing is that T is equal to 2 may. Now substituting it in the equation for A, we'll get T plus may by 2 is equals to max root 3 by 2, that is we'll substitute T as 2 may. Hence ay is equals to 5ay is equals to root 3 ax. Substituting ax in this equation, we'll get 3mu square by L is equals to 2 may plus 3m root 3 by 2. What is ax? 5 by root 3 ay plus 3m ay by 2. Cancelling root 3, and we will get here 5 plus 3 by 2 is 5 into 3 by 2, 15 plus 3 by 2 plus 2 into may, which will give us 11 may is equals to 3mu square by L. Hence ay is equals to 3u square by 11L. And this is a very important result to solve the question further. Thus tension is equals to 6mu square by 11L. Now think logically. With respect to the ground frame, force will be force on each of the discs would be tension on the disc, tension force of the rod on the disc divided by mass of disc. Thus acceleration of A will be 6u square by 11L. Acceleration of B will be 3u square by 11L, and acceleration of C will be 2u square by 11L. And that's our answer. Hence we'll get option C as the correct answer. Now one may wonder that why P does not have finite velocity. There can be a case that P will be constrained to move with some finite velocity. Yeah, it may be constrained to move, but assume that P has some velocity along rod C as suppose P has some velocity along rod C equal to ur and perpendicular to rod C as u theta. So if it has some velocity along rod C, we know that C has no velocity initially. So velocity of C along the rod is 0, and if P has some velocity along the rod, then the rod will try to get compressed, which is not possible since it's written these are light identical rigid rods. Yes, we assume rods to be rigid, that is why it will not have some velocity along the rod. Similarly, it cannot have some velocity perpendicular to the rod because if it has some velocity u theta perpendicular to the rod, it will have some component of velocity 30 degree, that is u theta cos 30, along the rod connecting P and A. Thus the rod PA will get compressed, which is not possible. That is why P will have zero velocity at the initial stage. Hope you understood the problem and got to know more interesting concepts. Thank you. Have a nice day.